This is the second video where we'll work through some exercise questions. You can pause the video, set up the question, and then you can watch the solution. So number 7, we have the absolute value of negative 12 divided by 4 plus 2 times the absolute value of negative 2 cubed divided by 4. So we've got a lot going on here. Notice that the first thing that we need to worry about are the absolute values. So we're going to focus on those two areas first. The absolute value of negative 12 is just 12. In our second set of absolute value bars, we have operation to do. This is negative 2 cubed. So this is negative 2 times negative 2 times negative 2, which results in negative 8. But because that's in absolute value bars, it's going to actually become 8. So we're going to have 12 divided by 4 plus 2 times 8 divided by 4. That looks a bit wonky. Let me just get that 8 looking nicer. Okay, so getting rid of those absolute value bars helps a lot. Now we have division, adding, multiplication, and division. Well, we know that we should work left to right when we have division and multiplication. And we do have an adding symbol here. So we're going to be able to divide here, 12 divided by 4. And then after the adding symbol, we'll be able to work left to right. So the next operation we can do is multiplication, 2 times 8. So 12 divided by 4 is 3. And 2 times 8 is 16. And then we can write everything down here. Now we have adding and division, so we must do division first. So 16 divided by 4 is 4, plus 3. Now we just have adding. 3 plus 4 equals 7. For number 8, we have 6 minus 8 times the absolute value of 2 minus 3 times 4, plus negative 5 squared divided by 5 squared. So again, we want to focus on BEDMAS, and absolute value comes first. So we're going to do everything inside the absolute value following BEDMAS rules inside those absolute value bars. We have 3 times 4, have to do that first. That equals 12, and then we have 2 minus 12. This point, we can add the opposite, giving us 2 plus a negative 12 in our absolute value bars. 2 plus negative 12 results in a negative 10. But because that negative 10 is in the absolute value bars, that's going to change to become just 10. Now I can rewrite with everything from above. 6 minus 8, which will multiply to 10, plus negative 5 squared divided by 5 squared. Now we can do exponents. So I'm going to take a look at the negative 5 squared. This means negative 5 times negative 5, which is a positive 25. And then our 5 squared is just 5 times 5, which is also a positive 25. So I'm going to write the division there. Plus 10, multiply 8, and then 6. So now I have 6 minus 8 times 10 plus 25 divided by 25. I have subtraction, multiplication, adding, and division. I'm going to multiply and divide before I add and subtract. So I can do 8 times 10, and I can do 25 divided by 25 because they're separated by this adding symbol. So 8 times 10 is 80, and then I can write 6 minus 80 plus 25 divided by 25 is 1, and now I have subtraction and addition. Remember, when you have both subtraction and addition, you work left to right, but I'm going to change the subtraction to addition and change the positive 80 to its opposite, which is negative 80. And now I have 6 plus negative 80 plus 1. I can combine my positives together. 6 plus 1 is 7, plus negative 80. And I can see that clearly I have way more negatives than positives. So my answer is going to be negative, and I'm going to subtract 80 minus 7, which is 73. And so I will have a negative 73 as my result. For number 9, we have negative 6 plus 3 squared minus a negative 7 on the numerator, and 7 minus 9 minus 3 on the denominator. We're going to solve the numerator separately from the denominator and then see what kind of fractional result we get. I can see that in the numerator I have a minus a negative, so I'm going to get that out of the way first. I'm going to add the opposite here, giving me adding a positive 7. I have a 3 squared, so I need to do the exponent first. 3 squared is 3 times 3, which is 9, plus negative 6, plus a positive 7. So I'm going to combine my positives together. 9 plus 7 is 16, plus a negative 6 means I have more positives than negatives. So my answer will be a positive 10 on the numerator. For the denominator, I have 7 minus 9 minus 3. I'm going to add the opposite here. I'm going to add the opposite and add the opposite. And now what I see I have is 7 plus negative 9 plus negative 3. So I'm going to put the negatives together. Negative 9 plus negative 3 is negative 12. Plus a positive 7 means I have more negatives than positives, so I'm going to have negative 5. So my numerator is 10 and my denominator is negative 5. Remember that the fraction bar means division, so we can look at this two ways. We can reduce it down to lowest terms like a fraction, or we can divide up like we do to change to a mixed number. 5 goes into 10 twice. 10 divided by 5 is 2, but this is positive 10 divided by a negative 5, so the result here will be a negative 2. For number 10, we have quite a lot to do for both our numerator and denominator. When I have this much to do, what I like to do is rewrite it. So the numerator is negative 9 plus 18 divided by negative 3, that is multiplied to negative 6. So sometimes I change from a bracket to a symbol to make it more clear for myself, and you can use an X, the typical times symbol, as well. So now I can solve. I'm going to focus in on that I have division and multiplication before adding, and because I have division and multiplication, I'm going to work left to right. So 18 divided by negative 3 results in a negative 6 times negative 6 plus a negative 9. Now I'm going to multiply negative 6 times negative 6, which is a positive 36, plus a negative 9. Negative 9 plus 36, I have more positives than negatives, so my answer will be positive, and I will subtract 36 minus 9, which is 27. So I will have positive 27 for my numerator. For the denominator, I have 32 minus 4 times 12 divided by 3 times 2 plus 3. I've got subtraction, multiplication, division, multiplication, and adding. I'm going to need to multiply and divide left to right. So my first step is going to be negative 4 times 12. Or you can see it as just 4 times 12. Maybe I'll do that. So that's going to be 48. And then we write that 32 minus 48. Now I can go ahead and I'm just going to write everything again just to be safe. Now I see that I have division and multiplication, and the division comes first. So I'm going to divide 48 divided by 3 before I multiply 3 times 2. So I'm going to take 48 divided by 3, which is 16. That's going to be multiplied by 2, and I copy everything else out. Now I'm going to multiply 16 times 2, which is 32, plus 3, and then subtraction. Now I have 32 minus 32 plus 3. Well, I can do the subtraction first. It's leftmost, so I need to. 32 minus 32 is 0, plus 3 equals 3. So that's my denominator. My numerator is 27. My denominator is 3. 27 divided by 3 is 9. I want to point out one thing that happened over here with this sign way up here. If you wanted to, at any point, you don't like the look of the subtraction, you can add the opposite, and that will never affect how you do the order of operations. Okay? So if you made this a plus -4, and that went all the way through, you would still end up with the same result of 3. I'm going to show a couple fraction questions now. Number 13, we have a half plus a half squared minus 3/8. So for this question, BEDMAS tells us we do exponents first. So I'm going to have half times half. That happens first. And half times a half equals 1/4. So I have 1/4 plus half minus 3/8. I have adding and subtracting. I have to add before subtracting because it's leftmost. So I'm going to be adding a half plus a quarter. These are unlike fractions, so I'm going to make them like fractions. 2/4 plus 1/4 equals 3/4. So I will have 3/4 minus 3/8. Again, unlike fractions, so I'm going to change the first fraction to have the common denominator, and that will be 6/8 minus 3/8. And so the result here will be 3/8. For number 14, we have brackets. So we need to solve what's inside the brackets first before we divide. We see we have unlike fractions and subtraction. So we're going to multiply the second fraction to raise its terms, giving us 7/8 minus 6/8. That results in 1/8 divided by 3/2, which we know we need to keep, change, and flip. So we take 1/8 times 2/3, and then we can cross reduce. Divide by 2, divide by 2, giving us a result of 1/12. 17 and 18 are both fraction questions where we have in 17 exponents, and in 18 we're going to have some negative fractions. So number 17, we have 9 times 1/3 cubed times 4/3 squared. So we need to do the exponents first. 1/3 cubed is 1/3 times 1/3 times 1/3. So we're going to go ahead and multiply that out. 1 on our numerator. 3 times 3 is 9, times another 3 is 27. So we're going to have 9 times 1/27. And then we have 4/3 squared, which is 4/3 times 4/3. and that equals 16/9. We're going to keep that as an improper fraction. So this is going to be 9 times 1/27 times 16/9. In order to make this look a bit better, we can pop that 9 over 1. Now we have multiplication. So we can technically go in any order, and we can cross-reduce any which way we want, actually, because we have only multiplication. Just like adding, we can switch the order around. So I'm going to cross-reduce here, and I see that I have 9 and 27, so I'm going to divide 9 by 9 and 27 by 9, giving me 3. And that looks like that's about all I can do here. I have a fraction now in the first one, 1 over 1. That's basically nothing, right? It's just equal to 1. So I can ignore that, or I can multiply my numerators. 1 times 1 times 16, which is 16. And then in the denominator, 1 times 3 times 9 is 27. So the result here is 16 over 27. For number 18, we have exponents, and then we've got all these yucky subtraction signs. Let's worry about the exponents first. We've got a third squared. Let's do that first. Oh, and we've got brackets first. Pardon me, let's do the brackets first before the exponent. So we have 5/6 minus 7/12. So I'm going to change that one. That's going to give me 10/12 minus 7/12. So that's not so bad. That's going to equal 3/12. I'm going to leave that the way it is. I could reduce that, but I'm just going to leave it for now, because I usually don't reduce anything until the end if I have to. So that's 3/12 minus 3/4, which is being multiplied to 1/3 squared. Okay, well then now I can do this, the exponents. 1/3 times 1/3, that's equal to 1/9. So I'm going to rewrite again. 3/12 minus 3/4 times 1/9. Well, I can't subtract until I multiply, so I'm going to multiply 3/4 times 1/9. I can reduce here and here, divide by 3, and that equals 1/12. So that is done. So 1/12. And now I've got 3/12 minus 1/12. So that worked out great. I don't have to do any add the opposite, so you never know. And I don't have to even change the fractions now. So that's going to be 3/12 minus 1/12, which is equal to 2/12. And now I'll reduce that fraction to lowest terms. Divide by 2 and divide by 2, giving the result of 1/6.